Welcome to the Bible and Science. This is Dave Prentice. I'm a retired public high school teacher, certified in all branches of science and math. I've also taught on the Bible and Science for many years, both in the U.S. and on many overseas mission trips. This is episode 23 of the Bible and Science. We've been dealing with the age of the earth, which we'll continue to do today. So this is part 3 of the age of the earth. We already talked about radiometric dating, and we're going to be getting into some geologic features that are supposed to have taken millions and millions of years to form. The reason people believe the earth is old is, number one, that's what they were told. Number two, the belief that it takes millions of years to form a fossil. Number three, they misunderstand radiometric dating, which is what we talked about a bit last time. And then also they think that geologic features such as the separation of the continents, the Grand Canyon, and so forth, took millions of years to form. Well, those are not good reasons to believe the earth is old. If you believe in radioactive dating, radiometric dating, then you compare that to the strata on the geologic scale. And if the stratigraphic ages, the ages determined by what the rock layer is, if those are really correct, and if radiometric dating is reliable, then we should be able to find a great multitude of tie points, that is, volcanic rocks, igneous rocks, that match the assigned layers, ages, based upon stratigraphy, what strata they are. But evolutionists don't depend on high points because there's so few of them. If you look throughout the geologic literature, you're only going to find 100 or so individual rocks, that is called tie points, that have been found that match their assigned ages. We decided how old they are, and then we collect samples, and every now and then somebody will date one of those to see if it matches. And out of the thousands of rocks that have had this procedure done to them, only a very small minority, somewhere in the neighborhood of 100 or so, that match the age. The vast majority don't match the age, so evolution says it should be this much, so therefore let's just throw out the age that we obtained by testing. Instead of discarding the data when it doesn't match, instead of discarding the theory when it doesn't match the data, let's discard the data when it doesn't match the theory. So the reason people believe the earth is old is that's what they were told. They believe it takes millions of years to form a fossil, and they don't understand correctly about radiometric dating, which is what we talked about last time. Then let's get into some of the geologic features, such as the separation of the continents, the Grand Canyon, and so forth, that are supposed to have taken millions of years to form. If you look on that animation, you'll see the plates moving around, the continental plates. The idea of plate tectonics actually came out of the Bible. Genesis chapter 1, verses 9 to 10 says there was originally one landmass. On that, evolutionists agree with that. The evolutionists will call this Pangea, and they believe it broke up over hundreds of millions of years. Well, we disagree on that. Young Earth creationists believe the split took place rapidly during and after Noah's flood. So there was one supercontinent before then, but then it split. Geologists around the world use a computer program called Terra to model the motion of the continental plates. Very few realize that the Terra program was written by Dr. John Baumgartner, who's a young Earth creationist, whom I've had the pleasure to meet several times. The Terra program, works much better if the continents were moving rapidly for a short time rather than slowly for millions of years. So, for instance, if they're moving very slowly over millions of years and they bump up against each other, they're just going to kind of stop. But if they're moving fairly rapidly and they hit each other, what are you going to get at the boundaries? Mountain ranges. And that's what you see. So let's consider the most obvious of the geologic features that people say took millions and millions and millions of years, the Grand Canyon in Arizona. It's a mile deep, 8 miles across, over 200 miles long. So evolutionists believe that the Colorado River eroded the Grand Canyon. It took millions of years for that to happen. So is there any evidence that the fundamental assumption of evolution, uniformitarianism, is wrong and that large-scale erosion can occur quickly? Uniformitarianism says that everything happens, the geologic processes, by slow, steady, gradual processes. And the slogan that's repeated over and over and over again is the present is the key to the past. Well, how do you know that? Can you see in the present that it would indicate we could form something like what happened in the past, very slowly, steady, and gradually? Well, I think that one of the things that points us toward the idea of what happened at the Grand Canyon would be Mount St. Helens, the volcano up in the state of Washington. It's in southwest Washington state, and up until it erupted in 1980, that's what it looked like. It was a beautiful, classical, snow-capped volcano. So this is where Mount St. Helens is. It's up in the state of Washington. The Grand Canyon, by contrast, is down there in Arizona. But the processes at Mount St. Helens, I think, give us a clue about how the Grand Canyon was formed. There's a small lake up there at Mount St. Helens. It's called Spirit Lake. And before the eruption of the volcano, this is what Mount St. Helens and Spirit Lake looked like on the left side. Afterward, an eighth of a cubic mile of rock was blasted off the top of Mount St. Helens, and a lot of it landed in Spirit Lake, and it caused a very, very, very high wave that swept millions of trees off the shore. When the initial steam blast came out, it knocked down millions of trees. The steam blast, not just the wave, but the steam blast, it just went, I believe it was supersonic, and it knocked down enormous quantities of trees. In addition to that, there was an eighth of a cubic mile of rock from the top of the volcano, and it crashed into Spirit Lake. It created a wave hundreds of feet high that swept down millions more trees. So you had a lot of trees leveled by the blast, and you also had a lot of trees leveled by the wave. So if you look at what's in the right-hand picture that looks like an island, no, those are floating log rafts. They would float, and then gradually one end would get waterlogged first, the root end, and then it would turn downward, so the root end was downward, and the other end, which was stripped of leaves and so forth, it would remain near the top, and so you had millions, or at least hundreds of thousands of trees settling in the bottom of Spirit Lake, and it looked just like some formations that we had seen at Yellowstone previously. And the U.S. Geologic Survey, the Park Service, used to say that was multiple forest growth. Now it turns out when we saw Mount St. Helens, oh, this can happen in a short period of time. During the eruption, the ash from Mount St. Helens circled completely around the globe. The energy released from that one medium-sized volcano was estimated to be the equivalent of about one Hiroshima-sized atomic bomb per second for 9 hours. And this is only a medium-sized volcano. So when Mount St. Helens erupted, it deposited hundreds of feet of very finely laminated sediment into the North Fork of the Toutle River in just a few days. The sediment was very hot. The water in it quickly evaporated, so the sediment quickly turned into rock, sedimentary rock, and it dammed up the river. About 20 months later, there was a new mud flow that came out, and it broke through the new rocks. It carved out a canyon about 1/35th as deep as the Grand Canyon. How many millions of years did that take? It took one day. The Toutle River didn't carve the canyon, it just drains the canyon. It looks like it carved it, except we were watching the whole thing happen, so we know better. So this is very similar to the Colorado River and the Grand Canyon. At Mount St. Helens, here are some pictures courtesy of Raymond Fleshman. Those thin laminated layers didn't take millions of years to form. It was just a few days. You had the first mud flow that came out, and it was traveling very fast, and it laid down a skin and another skin and another skin and another skin and another skin. In just a few days, you have hundreds of feet of finely laminated sediment. So there's thousands of layers, and it didn't take thousands of years. It was just a couple of days. There's something that evolutionists depend upon, the law of superposition. This was first formulated by Nicholas Steno in the 1600s. Now, if you look at the arrangement of rock layers as shown in the geologic column, it's fairly consistent worldwide. But there are hundreds of exceptions where the strata considered older are on top of the strata considered younger. The ages that are assigned to the strata depend upon Steno's law of superposition, which was formulated in the 1600s. It says that in undisturbed rock strata, keyword undisturbed, the oldest rocks are going to be at the bottom. One time I was teaching this in one of my classes, and on the test, I emphasized this is the law of superposition. You don't have to believe it, but you have to know what it says. Okay, on the test, I asked, what is the law of superposition? And one of my students who was really paying attention very well said, oh, well, some positions are so great that they're superpositions. Okay, he did well on his test, as you can imagine. So the so-called law of superposition is not a law because it's been falsified. If you find an exception to a law, you could call it perhaps a principle or something like that, but not a law. Well, it's been falsified. His law holds only when sediment is deposited under very gradual quiescent conditions, not flowing. But there have been experiments done at the University of Colorado, and we can observe the mud flows at Mount St. Helens, and they both show that if the sediment is moving, the bottom layers may not be the oldest. And I want you to pause my video here, and I want you to go to YouTube and look up a series of videos. Guy Berthaud originally did them. He's a French guy. He did a series of videos called Drama in the Rocks, parts 1 through 4. If you search for the terms drama in the rock and also put the word sedimentation in there, he has 4 parts of his video, and he shows this is not just theoretical. He actually did experiments in laboratory conditions where he built a very large sluice and dumped in sediment and had flowing water, and you can see on film how these things formed the strata, and it didn't take millions of years, and the ones on the top are not necessarily the newest, the ones on the bottom are not necessarily the oldest. It depends. If there's a flowing current, then all bets are off. So you should definitely go watch those videos. Okay, when Mount St. Helens erupted in 1980, the Toutle River Valley was filled with hundreds of feet of superheated mud. It rapidly hardened into rock. That's viewed from the visitor center at Mount St. Helens. That's called Engineers Canyon, the whole network. That's viewed from about 2 miles away. Then, a couple of years later, January 1982, a second eruption sent more superheated mud blasting through the newly formed sedimentary rock. It was still soft enough that the new eruption was able to blast through. It formed a network of canyons up to 160 feet deep. That's viewed from 2 miles away, so it doesn't look that deep, but it's 160 feet deep. This is 1/35 as deep as the Grand Canyon, And how many millions of years did that take? It took 1 day. The Toutle River did not carve those canyons. It was there before, and it simply drains the canyons. Well, you might say, "Oh yeah, but sedimentary rock, that's soft rock. That can't happen. It's no biggie." Okay, let's look at hard rock. This is also at Mount St. Helens, viewed from the visitor center, and the arrow is pointing toward a canyon going through the Goat Rocks. Hard rock erosion should be much slower than soft rock erosion, but besides the flow of mud that carved out the sedimentary canyons, there was a steam blast that came out of Mount St. Helens when it erupted, and it blasted out a 700-foot deep canyon through the solid granite of the Goat Rocks. Granite is a whole lot harder than sedimentary rock, so we would look at that and say that had to take millions and millions of years. No, you know how long it took? One afternoon. So if you look at the geologic column, the ages on there, the names have to do mainly with where the collection of fossils was first found, but the ages were assigned based on the assumption that evolution had really taken place, that there was never a worldwide flood. Remember, Peter cautioned us about that in 2 Peter chapter 2, that in the last days scoffers will say everything continues slowly and gradually and there's never been a worldwide flood. That's uniformitarianism. Those ages come from the assumption of uniformitarianism, which is an untestable, unprovable idea. The present is the key to the past. How are you going to test the past? You can't. But we were warned by Peter. How do fishermen know anything about geology, huh? How do we identify those layers? Well, rather than using any kind of radiometric dating technique, geologists identify each rock layer, Cambrian, Ordovician, Silurian, Devonian, and so forth, by a clearly defined community of fossils. It's called a suite of fossils, like a suite of hotel rooms. The suite of fossils for Cambrian is essentially the same no matter where in the world we find it. The suite of Ordovician is different, but it's the same throughout the world and so forth. So if evolution really occurred, then different types of living things, from amoebas to humans, would have had to evolve at different rates, in different places, at different times. We shouldn't find any worldwide pattern of clearly defined communities of fossils, but yet that's precisely how we identify that a rock is Cambrian. We look at this suite of fossils in it, or Ordovician, Devonian, and so forth. Each suite of fossils has its own characteristics identifying suite of fossils. So evolution says no, things would have occurred, would have been evolving slowly, steadily, gradually around the world. Evolution is clearly wrong. It's wrong. So how were the ages originally assigned? Suppose someone, and this was in evolutionary terms, according to uniformitarianism, if someone found a new fossil that was previously unknown, it'd be compared to the rocks where it was found to see if they contained a known suite of fossils, Cambrian, Devonian, and so forth. If so, the new fossil was assigned the same age as that suite. Even if there wasn't a full suite of fossils, you'd look for individual fossils nearby, and some fossils are known only to occur in one particular suite, so they can be used as index fossils. So the suite of fossils, and we found this one fossil in it, so that's the previously assigned age that will then be assigned to this one fossil. Okay, so we use it as an index fossil. But if none of the other fossils had already been assigned an age, then that person would decide how highly evolved the new organism was and assign an age based on the assumption that evolution had taken billions of years, roughly 3.5 billion years since the oldest known fossils, the stromatolites. So he would see he or she would see how far along does it seem to be on its evolutionary path. That must be how old it is. So finally, if we've got this new fossil that we've just assigned an age to, and it's found only in one suite of fossils, then the new one could be used as an index fossil, and its assigned age would be used anywhere that suite was found. So any new fossils found in the same layer would automatically be assigned the same age. It's kind of a circular argument, isn't it? You date the rocks by the fossils and you date the fossils by the rocks. Okay, so let's get back to the Grand Canyon. We were talking about Mount St. Helens because it applies to the Grand Canyon. The Grand Canyon is a mile deep, it's 8 miles wide, 216 miles long. It's a gash through an uplifted area of the Colorado Plateau in North Arizona. The Colorado Plateau is more than just Colorado. It's about 4 states. So if you look on the picture there, it's a U.S. government satellite photo of the Kaibab monocline. It's a mile-high area. It's an upwarped formation at the end of the Grand Canyon. So in order for the Colorado River to have carved the canyon, it would have had to flow a mile uphill for millions of years. You know, I did an experiment when I was in the Grand Canyon area. I jumped and I came back down. Gravity works in Arizona too. So we've got an upwarped area out in the desert, and the Colorado River, which is coming from north toward south, suddenly makes a sharp bend toward the west. Is that just gravity working? Well, could the Grand Canyon be the result of slow erosion? That's a geologic map of North America, and right there is the Colorado Plateau. So you can see that the Colorado River is coming from north toward south, but then it suddenly veers sharply toward the west. So the Kaibab monocline would have served as a natural dam holding back 4 states worth of water at the end of the flood until something caused a split right there where the red oblong is and the arrow pointing down at it. Something had to cause a split. The Colorado River didn't carve the canyon, it just drains the canyon. The Colorado Plateau east of the Grand Canyon includes many parts of Utah, Colorado, Arizona, and New Mexico, and these are not on the same level as the Kaibab monocline. So we've got a natural dam there, Kaibab monocline, and all of the water stored over there at the end of Noah's flood, and suddenly something happened to cause a little crack. It's commonly called a water gap. So the little crack opened away, like the old legend about the little Dutch boy with his finger in the dike. When he pulled his finger out, he knew that the whole thing was going to collapse. So something happened to open a little crack, and all of this water, 4 states worth of water, is going to now begin to flow through. So there's, you see the Colorado River coming north to south, and then it turns sharply to the west and runs uphill for a mile for millions of years to form the Grand Canyon. I don't think that's plausible. The Grand Canyon is missing over 1,000 cubic miles of sediment. That's enough to make a good-sized mountain range. But yet, the delta of the Colorado River, it's just a normal-sized delta composed of soft, relatively recent sediment. That's a NASA photo of the Colorado River Delta at the beginning of the Gulf of Colorado. So if the Colorado River carved the canyon over millions and millions of years, there's 1,000 cubic miles of sediment. Where did it go? I don't think that it carved it over millions of years. It looks to me like when the water rushed off of North America, it must have carried most of that sediment out into the Pacific Ocean. So if the Grand Canyon really took millions and millions and millions of years to form, then you would have all of these different rock layers. And how many do you have? You have just a few rock layers. At the Grand Canyon, there's only 6 strata that are present. The Permian, Pennsylvanian, Mississippian, and Devonian, and Pennsylvanian and Mississippian together called Carboniferous. Then you also have Cambrian and Precambrian. The Grand Canyon is the most complete section of the geologic column known in the entire world. Let me repeat that. In the entire world, this is the single most complete section of the geologic column. And it contains only 6 of the strata. So all of those things that you see piled up in the textbooks, they're purely the result of somebody making up a geologic column. The gap from Cambrian to Devonian is supposed to represent over 70 million years of missing fossils. The Ordovician, the Silurian, they're all missing. Well, could the Colorado River have carved out the Grand Canyon? There's not enough water. So throughout the Grand Canyon, you'll see many mesas and buttes where the Colorado River at present does not flow. That little river down there at the bottom of the Grand Canyon, every now and then it'll rise up somewhat during heavy rainfalls, but it never reaches anywhere near the top. It's a mile down. So in order for the canyon to get scoured out, there had to be a much, much larger quantity of water at some time in the past. Well, I think I'm going to have to go with what the Yavapai Indians say, those that live at the Grand Canyon. They believe that it was carved by the receding waters of a great flood. Well, that would match with what the Bible paints for us as the picture of what happened. Now, here's another little interesting thing. There's an area of the Grand Canyon called the Red Wall Limestone. It's a layer of the Grand Canyon that's several hundred feet thick and it's spread over thousands of square miles. It was previously thought to be devoid of fossils. It just lay down slowly, steadily, and gradually. Uniformitarianism geology says it was deposited slowly over hundreds of millions of years. But then Dr. Steve Austin, one of those pesky creationists, he reported in 2002, and Dr. Austin has gone rafting down the Colorado River many times doing geologic investigations. So he reported in 2002 at the Geologic Society of America that rather than being devoid of fossils, oh no, there are billions of nautiloids, billions, preserved in a 2-meter thick layer of the red wall limestone. So if you look at the pictures on the screen, that's what a nautiloid fossil would look like. They have soft bodies inside of a shell, and the bodies decay quickly when they die. But the shells at the red wall limestone are all pointed in the same direction. That would indicate that they were deposited by some sort of a flowing current. Rather than just sticking straight up in there, they're all leaning toward the same direction and leaning about the same amount. This would indicate that they were deposited by a massive sediment flow over a few days, not over millions of years. Well, I mentioned before that it looks like there's a crack in the Kaibab monocline, and that the water must have started flowing through, and like the little Dutch boy worried about pulling his finger out of the dike, it got wider and wider and wider. Well, not too far from the Grand Canyon is something we call the petrified forest. It's not really a forest. It's tens of thousands of trees and tree fragments lying on the ground. They don't have roots, they don't have limbs, they don't have leaves or anything like that. It's just large sections of trees. Most geologists believe that this whole thing is what's called an allochthonous deposit. That is, the trees floated into the area from somewhere else. Millions of trees or tens of thousands of trees floated into the area from somewhere else and were suddenly dropped down when the water flowed away. That's a lot of water. We don't know for sure what would have caused the initial crack at the Kaibab monocline, but it got there somehow and all the water rushed out. Where did it go? Well, the highest mountains in the world today are in the Himalayas, about 5 miles above sea level, and the Andes, about 4 miles. So those who've been to the tops say, yeah, there are seashells up there. How can that be? Well, there are many mountain ranges assigned to the Cenozoic era after the KPG boundary, which we'll get back to later. Before the flood, the mountains were not nearly so high. This is what the Bible says. The waters stood above the mountains. At your rebuke they fled. At the voice of your thunder they hastened away. They went up over the mountains. They went down into the valleys to the place which you founded for them. You've set a boundary that they may not pass over, that they may not return to cover the earth. So after these rocks were laid down, the top sedimentary layers found in the mountains rose and the valleys sank, including the seafloors. So not only did the tectonic plates move sideways, they also moved down. Where did all the water go? Into the oceans. It's still there. It's just the oceans are deeper and the mountains are higher than they were before. Obviously, you could study up on this for year after year after year and never exhaust the topic, but I'm trying to give you a brief introduction. So next time we'll talk a little bit more about some of the sedimentary features that are hard to explain in terms of slow, steady, gradual deposition and erosion and so forth. Also, we'll get into some things that I think are common deceptions, which are the gap theory and the idea that the days of creation were actually millions of years. See you then. Or I guess you'll see me then. I won't see you.